For the following exercises, determine whether there's a minimum or a maximum value for each quadratic function, and then we need to find that value and the axis of symmetry. Okay, so this is the last question in this bunch. So we've done tons of videos that goes more in depth into this. So this one will kind of just be a brief overview. If you need to get more context, you can always check out our quadratic functions playlist. The link is in the description. And yeah, you'll have access to all of the videos that we have done for quadratic functions. So let's get down to it. We know that the minimum and the maximum value, right, basically comes from the vertex, right? But more specifically, it's going to tell you if your quadratic function is smiling or frowning. Remember, there's two different functions for quadratics, right? You're either frowning or you're smiling. If you have a minimum value, right, that means that you have to be smiling. There is a minimum here at the vertex. So the minimum is the smiley and the maximum is the frowny, right? If you frown, you have a max vertex, right? Now, how do I know whether this is frowning or smiling, right? The answer lies in the a value of your quadratic function. If your a value is positive, positive goes with smiling, right? If you're positive, you're smiling. You would have a minimum. And if your a value is negative, it's frowning, it's negative, you would have a max value. So that breaks that down. So let's just quickly run through if we had a min or a max for both of them, because we can kind of grab them in one shot. If we're looking at this quadratic function, f of x equals 1/2 x squared plus 3x plus 1, what is my a, b, and c value for this one? Remember, the a value is always the one that's in front of the variable squared, so x squared or y squared or t squared or a squared, whatever. The b value is always the one that's in front of just the x, and the c value is the one that's all the way at the end. So they have it nice for you, a, b, and c. Your a value in this case would be 1/2. Your b value would be a 3, and your c would be a 1. Key in on your a value. Your a value here was a positive number. It was a fraction, but it wasn't negative 1/2. It was a positive 1/2. So that means that this is a smiley graph, and we would have a minimum. So I'm just going to write over here that we know that there's a minimum value for this graph. And if we just quickly run through the a, b, and c for the other one, and I'll write it down over here, a, b, and c. The a value is in front of the x squared. And notice how I'm taking into consideration that sign. The b value is the one that's in front of just the x, and take notice that I am taking that sign into consideration. And the c value is all the one by its lonesome. So in this case, my a value would be a negative 1/3. My b value would be a negative 2, and my c value would be a plus 3. Look at the a value to give you context of whether you have a min or a max. You have a negative value here, so negative goes with the frowny. This graph would look like this, and you would have a max value. So I'm just going to write that over here. We have a maximum value for this. Okay, so we answered 1 out of the 3 questions. Now we just have to find out what the actual value is for each one of them, and whether what is the axis of symmetry. Okay, so the actual value of your min or your max comes from the vertex, just like we saw, and it is the k value. Keep in mind that from your vertex is always h comma k, right? And technically, h's are x's and k's are y's, right? Because any point always goes x comma y. So your value, if I just drew a quick graph, my value for, let's just say this is smiling, right? It's a minimum. The minimum would be showing you how high that minimum is. And if you're talking about how high, you're talking about the y-axis. So that's why that value is the k. The vertex, on the other hand, the x value, the h, is the one that is talking about when does the graph shift from left to right, meaning when does the graph turn from going down to turning back up. So the value for the minimum or the maximum value is the y value on your vertex. The axis of symmetry, is the x value or the h value of your vertex. So that's important to know. Now we just have to find out what h and k are. So the first thing is we always want to find out h before we find out k. And h is always just negative b divided by 2a. And we already got those numbers, so we can just plug them in. For this one, it would be negative 3 divided by 2 times 1/2. Let's do the math. I have a 2 on the bottom. I have a 2 on the bottom of my denominator, right? And I have a 2 in the denominator, so I can simplify 2 and 2. I could just get rid of this and say that it's 1 and 1. So this would be just negative 3 divided by 1. So my h value here would be a negative 3. Now, we found the axis of symmetry, technically, but you just have to say it in a special way. When we talk about graphs, we never talk about a graph in terms of k and h, right? A graph is always y comma x. But we know that the x is the h value, right? When we're dealing with our vertex. So all we have to say is the axis of symmetry, so I'll just say axis of sim, is x equals negative 3. So we find it as an h value, but the axis of symmetry is x equals negative 3, because that's what the graph is based off of. The second thing that we have to do is we have to find k. And k is f of h. All you're doing is you're just plugging in your h value into your actual graph. That's it. My h value was a negative 3, so all of the x's are going to have a negative 3 in them. So the graph originally was 1/2 x squared plus 3x plus 1. All you have to do is erase the x values and plug in that h value. So this would be a negative 3 squared now, and then plus 3 times a negative 3. And then we continue with the math. PEMDAS rules first, right? This is negative 3 times a negative 3. Negative 3 times a negative 3 is a 9. So I will say this is the same thing as saying a 9. And now I can do just this quick algebra, right? 9 and 2, there's really nothing I can do here. So this equals 9 over 2 plus 3 times negative 3 is a negative 9 plus 1. Now let's add and subtract fractions. You can easily just plug this into the calculator if you want. I'm just going to show you how to do it in a fraction form. As you can see here, there's only one denominator in which I want to get all the other numbers into the denominator of 2. But these numbers, anytime that you just see a whole number, remember it's always over 1. So I want to get each of these denominators into a 2. So I'm going to multiply the bottom by 2, which means that I have to multiply the top by 2 for each one of them. I have to play fair. So 9 times 2 is 18, 1 times 2 is 2. So instead of saying 9 over 1, this would be the same thing as saying 18 over 2. And 18 divided by 2 is 9. And then the same thing here. 1 times 2 is 2, 1 times 2 is 2. So this would be the same thing as saying 2 over 2. And 2 divided by 2 is 1. So they're equivalent. Now, I am adding and subtracting on the top, but I'm keeping the denominator exactly the same. So this would be 9 minus 18 is a negative 9 plus 2 over 2. Negative 9 plus 2 is a negative 7. And that's my k value. And remember, the k value is the value of the minimum or the maximum, right? The value is the k value. In this case, we have a minimum, so that value would be a negative 7 over 2. Oop, that's an ugly 2. And the axis of symmetry was x equals negative 3. And that's the two answers for the first one. Now let's do the same thing for the second example, just for more practice. So first thing we got to do is find h. Remember, h was equal to negative b over 2a. We did that work over here. So this would be negative, b was a negative 2, divided by 2 times a negative 1 over 3. So just clean this up. Negative times a negative is a positive, so that would be 2 divided by, I can't really do anything here, so this would be a negative 2 over 3, right? 2 times 1 is 2, divided by 3. And then I have this debacle where I'm dividing by a fraction. Remember the rule, right? Keep, change, change. So you swap them. So this would be the same thing as saying 2 times negative 3 over 2. And now I have a 2 in the denominator. I have a 2 in the numerator, 2 in the denominator. They can cancel. So it looks like I have an h value of a negative 3. I can't say that for my axis of symmetry. I have to say it in that fancy way. So axis of symmetry is x equals negative 3. And that's the answer to the first part. Now all I got to do is find that value, and in this case it's going to be the maximum value, right? And remember, that value is always just a k. So 2, we want to find k by doing f of h. You're plugging in that number for all of the x's in your formula. So this formula is negative 1 over 3 x squared minus 2x plus 3. So I'm just going to get rid of all the x's, and I'm going to include that value. So this value was a negative 3, and then times a negative 3. We got to do the exponents first. That's the PEMDAS rule. Negative 3 times negative 3 is a 9. So I'm just going to get rid of that and say that this is the same thing as saying a 9. And now we can simplify. Let's see. I have a 3 in the denominator. I have a 9 on the top. I can cancel that 3 out because I know that 3 times 3 is a 9. So now, negative 1 times 3 is equal to a negative 3. Negative 2 times negative 3 is a positive 6 plus 3. This one is easy. There's no fractions here, thank goodness. So I can just do the math. Negative 3 plus 6 is a 3, and 3 plus 3 is a total of 6, right? So this would be my k value. I'm just going to put it up here. So k equals 6. And remember, that's my max value. So I have a max value of 6. This was equal to a 6. And my axis of symmetry is really the h, which is x equals negative 3. But that's it. If you guys want to plot it, go plot it and see what the graph actually looks like. All right? So hopefully this helped. Let me know in the comments what you think. If you want, you can click the subscribe button. But if not, still love you anyway. Maybe I'll get you on the next one. I really hope that we're providing you great help for your math class, and we have physics videos as well as we have chem videos if you want to check those out if you're in those classes. But yeah, I hope you guys have a great day. I hope you're studying hard. Math is fun. It's like a puzzle. And yeah, thank you so much for tuning in, and I'll see you guys all in the next lesson. Have a great day.